Today we're finding the area of polygons through composition and decomposition. We have two objectives today. They are that we can show the area formula for the region bounded by a polygon by decomposing the region into triangles and other polygons, and that we can find the area for the region bounded by a trapezoid by decomposing the region into two triangles. Let's start by clarifying a new term. Our objectives state that we want to find the area of the region bounded by a polygon. In this case, let's look at two triangles. When talking about a triangle, the triangle consists of only the three lines used to outline the figure. When referring to the triangular region, we are describing the triangle and its interior. Let's begin by looking at a compound figure. In this problem, we're asking to find the length of two unknown sides. Let's begin by labeling the figure with what we already know. This means that our two unknown sides are side BC and side DC. Let's begin by focusing on side BC. In order to determine the side length, we need to pay attention to the side lengths on the opposite side of the figure. We can see how the lengths of side AF and side ED add up to equal length of the side BC. This means that we can find the length of side BC by adding 6 plus 7 for a side length of 13. Now let's look at side DC. To determine this side length, we again need to pay attention to the sides that run parallel to it. To find the length of side DC, let's first project the length of 10 downward to compare the two. We can see that this side length is far larger than the side we are looking for in DC. To help solve this, let's now look at side FE. When we project this line down, we see that 8 combined with line DC equals 10. We know that 8 plus 2 equals 10. This means that the length of line DC is equal to 2. Once we've found the lengths of each side, we can find the area by breaking the compound figure into two rectangles and finding the area of each. Let's look at a new compound figure. Our goal is to have multiple strategies for finding the area. Take out a pencil and paper so you can write down these strategies and use them later. The first strategy is to break our figure into rectangular parts and find the total area. Here, we can draw dotted lines to form three rectangles. We can find the area of the two equal top rectangles by multiplying the length times width. We can find the area of the lower figure by multiplying the length times width again. Notice that the side length of 9 meters measures the length of the entire compound figure. To find the length of the lower rectangle, subtract the upper length of 4 from the total length of 9. Totaling these areas gives us the full area of the compound figure. A second strategy is to turn our polygon into one large rectangle and subtract the missing area. Here we outline the perimeter of the rectangle in red to turn our compound figure into a rectangle. We can find the area of this rectangle by multiplying length times width. Then we can subtract the area of the rectangle missing from our compound figure to find the total area of our compound polygon. Use these two strategies when you start your problem set today.